function table? Okay, what's a function table? Nicole?
There's input and output and what the numbers are.
Very good. You have input, output, and there's a relation there. We usually use an equation. Sometimes we add numbers, values, an equation. So 3 times x plus 2 might equal what our y is, right? So we plug in numbers for x and solve for y. Okay. We talked about a ratio. Do you guys remember what a ratio is? You have your numerator and then your denominator. Well, today we're going to talk about slope, and we're going to apply some of the things we used in our previous units to learn this new lesson. If I asked you what a slope is, what would you think of? If I said, tell me what a slope is to you.
Like downhill or uphill.
Very good. Very, very good. So like downhill or uphill. Very good. So like skiing on a slope. Or you could there's tubing out Snow Creek, isn't there? Okay, so like uphill or downhill. Very good. Is this a slope to you? No, there's nothing there. Very good. And you're going to learn that this is horizontal. Very good. And we'll talk about that. And a negative slope. And then we have, this is undefined, and this is no slope. It's called linear equations. So we're going to be working with lines, linear lines, on the coordinate plane. Tanner, do you remember this axis?
Like the x and y.
Very good. Your x followed by your y. Which one do we always use first? X. Very good. Is our horizontal. And our y. We have our positive, negative, then positive and negative. Okay. Well, today we're going to work with slopes on the coordinate plane, and I'm going to teach you how to find that. And basically, it's just a simple ratio of your vertical, your change of your vertical, which is your y, which is backwards from what we've learned, over your change of your horizontal, which is your x. So it looks like a fraction. You have your slope equals change of your y coordinates over change of your x squared. But that's actually your second y coordinate, and then your first y coordinate, and your second x coordinate, and your first y coordinate. So if I had a point here, and I had a point in my third quadrant, and it formed a line, and I told you this was 3, 2, okay? And that this point here was -1, -4. Okay, what is the slope of this line? You would use your coordinate points and use your formula, your rise over run, okay? Now, students always say, well, which one's my 1 and which one's my 2? Really, I'm going to show you it doesn't matter which ones you use, you get the same answer. But let's for right now use this as our first coordinates and this is our second. So what is my y2 in this coordinate pair? Nicole?
-4.
-4 minus, what is my y1? Jacob K.
3.
The y.
Oh, 2.
Very good. So -4 minus 2 all over x2 minus x1. What's my x2, Rachel?
-1.
Okay. Minus, and my x1, Avery? Very good. All over, what's -1 minus 3? -4. So our slope, what's a negative divided by a negative?
Positive.
And can I leave it 6/4? No, I have to reduce it to 3/2. So my slope of these two pair of coordinate points would be 3/2. Okay? So I'm going to leave the formula up there, and I'm going to come around and help you. So we're going to do A and B. My coordinate points, I would like you to find the slope of 1, 1, and 2, 4. And then my second one, when you're done with that, find the coordinates of -1, 2, and -3. Okay, so you're going to do your change of y over change of x. So you're going to set up.
Do you draw?
You don't have to draw it. Okay. That's a good question. And I'm going to teach you a method where if it's a graph given to you drawn, you can't memorize over run, which is way easier. But I do want you to know the formula too. So just use your y2 minus y1 over x2 minus x. They just only give you coordinate points and say find the slope. Okay, so y2. It did? Let's switch. Okay, so go ahead and get your, okay? Is that what you got for?
Yeah.
Yes, because 4 minus 1 is 3 and 2 minus, so what would your slope be?